Hi everyone, I'm here again to discuss another topic in trigonometry, and this is what we call as trigonometric function values of non-acute angles. So when we say non-acute angle, so we will be concentrating on an angle or angles measures more than 90 degrees but less than 180. So we will be working on the trigonometric function values of choose angles. Now, in working on or evaluating the TFVs of non-acute angles, it would be helpful for us to work on the reference angle of each obtuse angle. So, how do we define a reference angle? A reference angle for an angle theta, for instance, is expressed in prime theta, which is the positive acute angle made by the terminal side of angle theta and the x-axis. So the main component or composition or a reference angle is made up of a positive it's so a reference angle is a positive acute angle which is composed of the terminal side and the x-axis. So the terminal side of angle theta. Now, working on each terminal side located on each quadrant. So we have an angle theta and the location of the reference angle. Now, if theta class is on the first quadrant, theta itself is the reference angle. Okay? If theta is if the terminal side of angle theta is on the second quadrant, so this will be the reference angle. So how can we come up with a formula that would calculate the reference angle whenever theta is or whenever the terminal side of theta is in quadrant 2. So if theta is in or rather if the terminal side of theta is on quadrant 2, so if the terminal side of angle theta is on quadrant 2. So reference angle is equal to, so the entire of this one is 180 degrees, right? And this is your theta. So to obtain this, we will less 180 by whatever the value of theta. So for instance, if theta measures 120, then reference angle equals 180 less 120. So your reference angle equals 60 degrees. And this is composed of the terminal side and the x-axis, which is a positive acute angle. So this is really the reference angle whenever theta equals 120 degrees. Now, if the terminal side is on quadrant 3, so here terminal side is on quadrant 3. Now, again, the entire value up to here is 180. And theta is greater than 180 if the terminal side lies on the third quadrant. So we can say that theta must be equal to, reference angle must be equal to to theta minus 180. Okay? So here, again, if the terminal side lies on the third quadrant. So reference angle is equal to theta minus 180 degrees. If, for example, if let's say theta equals 220 degrees, so the reference angle is equal to 220 minus 180. So the reference angle is equal to 40 degrees. So again, this is a positive acute angle, and this reference angle is made up of the terminal side and the x-axis. So this will be the reference angle. In the event that terminal side is on quadrant 4, so this is the reference angle. Now, the whole of this is 360. So what we're going to do to obtain the reference angle is to less 360 by angle theta. So for example, if theta equals 320 degrees, reference angle equals 360 less 320. So reference angle equals 40, which is again a positive acute angle and made up of the terminal side and the x-axis. So reference angle when terminal side is on quadrant 2 is defined by this formula. Reference angle wherein the terminal side lies on the third quadrant is defined by this formula. And finally, reference angle such that the terminal side of angle theta lies on the fourth quadrant is defined by this formula. Again, if the terminal side of angle theta lies on the first quadrant, angle theta itself is the reference angle. Okay, so more example. Find the reference angle for each angle. So A equals 218. So we know that the terminal side of A measures, of angle theta measures 218 is on the third quadrant. So this is 180. And then until here, so we have, let's say, let's say this measures 218 degrees. Okay. And reference angle when the terminal side of the angle theta is on the third quadrant, this is equal to theta less 180. So reference angle equals 218 less 180. So the reference angle here is equal to 218 less 180. So that gives us a value of 38 degrees. Now, reference angle 38 degrees is a positive acute angle again, which is made up of the terminal side of the angle theta and the x-axis. So this is your reference angle. For B, angle theta is on the fourth quadrant. So let's say this is the rotation of theta equals 315 degrees. So theta on with terminal side on quadrant 4 will have a reference angle equal to 360 less theta. So reference angle is 360 less 315. So the reference angle here is equal to 45 degrees, which is again a positive acute angle made up of the terminal side of angle theta and the x-axis. Okay, so now we're going to make use of the special angles which I have discussed to you last time, and the lecture video is also in my YouTube channel for your reference. So we're going to make use this time of special angles as reference angles. for us to come up with an exact value, with an exact trigonometric function value of non-acute angles. Now, we can find exact trigonometric functions, as what I was saying, with reference angles equals 30, 60, and 45. Now, we will be limiting the discussion here to come up with an exact value with a non-acute angle with reference angle equal to special angles. So, for instance, we're going to find the trigonometric function value for 210. So, this is non-acute angles, non-acute angle, and we will evaluate its trigonometric function. So, how do we do that? So first, let's work on the reference angle. So the reference angle for theta on quadrant 3 is equal to theta minus 180. Okay? So reference angle equals 210 less 180. So here, the reference angle is 30. And this is a special angle. Okay? Now, um, we have to recall the trigonometric function values for special angle, like particularly for 30, 60, 90. So this is 30, this is 60, and this is 1, 2, square root of 3 as our reference. Okay? So since the terminal side of angle measures 210 lies on the third quadrant, so since theta is on quadrant 3. So we're expecting that tangent and cotangent are greater than 0. The rest will be less than 0. Okay? And in reference, we're going to consider the trigonometric function value of special angle measures 30 degrees. Okay? So sine 210, cosine 210, tangent 210. So we're expecting that the other four trigonometric function values will be less than 0, and these are sine, cosine, cosecant, and secant. The rest will be positive. And we will be working on the trigonometric function values of special angle measures 30. And then for sine, so this is sine 30. So that's opposite over hypotenuse, so 1 half. So sine 210 is negative 1 half. And its reciprocal is cosecant, so this is negative 2. Now, for cosine 30, that is cosine 210. Of course, they will differ with the sign. So, this is adjacent side over hypotenuse. So, this is negative square root of 3 all over 2. And this will be equal to, and its reciprocal function, secant, will be equal to negative 2 square root of 3 over 3, which is the reciprocal of cosine, 210 degrees. Now, for tangent, so this is opposite over adjacent side. So this will be 1 over square root of 3, which is square root of 3 over 3. And this will be square root of 3. So we were able to identify the exact trigonometric function values of a non-acute angle with reference angle equal to special angle. So take note that they have the values for sine until cotangent 210 equals the trigonometric function value of angle theta measures 30. It's just that they will differ from the sine, since the sine values or trigonometric function values of angle theta measures 30 are all greater than 0, since the terminal side of special angles lie on the first quadrant. So that would be the difference. Okay. So find the trigonometric function value for 480. 480 exceeds one rotation. So we have to work on its coterminal angle first. So 480 is coterminal with So we have to less 480 by 360. And 480 and 480 class less 360 equals 120. So for an angle theta equals 120, so we're going to work on its reference angle, and this is on quadrant 2. So reference angle when terminal side of an angle is on quadrant 2 is equal to 180 less theta. So this is equal to 180 less 120. So the reference angle is 60. So we will still come up with an exact trigonometric function value of angle theta equals 480, which is which has a reference angle equal to special angle 60. So we have again the right triangle 30, 60, 90. So this is 60. This is 1, 2, and then this is square root of 3. Now, since the terminal side is on quadrant 2, we're expecting that sine theta and cosecant theta greater than 0. The rest are less than 0. Okay? So, sine 480, cosine 480, tangent 480, then cosecant 480, secant 480, and finally cotangent 480 can be obtained by working on the trigonometric function value of special angle measures 60. So sine 480 equals sine 60. So sine 60 is actually opposite over hypotenuse. So this is square root of 3 over 2. So this is positive and the rest will be negative. Negative. This is negative. Now for cosine, so this is adjacent over hypotenuse. So this is negative 1 half. For tangent, this is opposite over adjacent. This is square root of 3. So this becomes negative square root of 3. So the reciprocal for square root of 3 over 2. So this will be 2 square root of 3 over 3. And this will be equal to negative 2. And this one is negative square root of 3 over 3. So we were able to identify the trigonometric function values of non-acute angles by working on the reference angle, which are special angles. So find the trigonometric function value for 210. So we have angle or terminal side of this angle is on quadrant 3, and reference angle with terminal side on quadrant 3 equals theta minus 180. Since theta is 210 less 180, so the reference angle is 30 degrees. So I guess it's the same value with the first example. Okay, 210. So we will be just refer to the first example here. How about finding the trigonometric function value for 390? So again, 390 exceeds one rotation. So we have to work on the reference, rather angles coterminal with this. Smallest positive angle coterminal with 390. And that is 390 less 360. So this is equal to 30 degrees. So meaning it's a special angle. Okay, and the trigonometric function values will be all greater than 0 since the terminal side lies on the first quadrant. So we will actually evaluate the TFVs of 30 degrees as we evaluate the TFVs of theta equals 390. So sine 390, cosine 390, tangent 390, cosecant 390, rather secant 390, cotangent 390 is equal to the TFV of angle measures 30 and everything is positive. Same with 30 degrees. Okay. So again, this is your 30 degrees. This is 1, 2, and this is square root of 3. So sine 30 is opposite over hypotenuse. So this is 1 half. So this is 2. And then cosine is adjacent over hypotenuse. This is square root of 3 over 2. While this is 2 square root of 3 over 3. Now for tangent 390, so this is opposite over adjacent. So we have 1 over square root of 3 or square root of 3 over 3, while this is square root of 3. So these are the trigonometric functions values for theta measures 390. How about trigonometric function value for 405? So again, we're going to find the smallest positive angle coterminal with 405. And that is obtained by subtracting 360 from 405. So subtracting 405 by 360, we got 45. And likewise, we will be evaluating TFVs of angle measures 45 as we evaluate TFVs of angle measures 45. Since this is coterminal with angle measures 45, so all the trigonometric function values are greater than 0. And we're going to consider the 45, 45 right triangle. And one, this is 1, this is square root of 2. So sine 405 is equal to, so either of the two angles can be considered as the reference. So 1 over the longest side. So this is 1 over square root of 2 or square root of 2 over 2. Now cosine 405 is also adjacent over the hypotenuse. So this will be likewise square root of 2 over 2. Now, tangent 405 rather is equal to opposite over adjacent. So this is 1. So the other values are the reciprocal of the 3 here respectively. So we have cosecant 405 equals square root of 2. Same with secant 405 equal to square root of 2 also. Cotangent 405 equals 1. So we were able to evaluate the exact trigonometric function values of non-acute angles by working on the reference angle. If the angle theta exceeds one rotation, so we will first work on the smallest positive angle coterminal with that angle theta. And it would be easier for us to evaluate the trigonometric function values if the reference angle is special or if the reference angles are special angles. So that's it for now.